This video is really important because it's the first time ever that a piece of mining machinery was flown by wire into a mining face 4,000 feet underground. And so this is a jumbo drill. It's really a robot, a mobile robot with 2 robot arms, and it's being run from a surface operation, and those 2 robot arms are being positioned in there. We stole that interface off the game, some gamers interface, and we provided a compass rose, an altimeter, and XYZ coordinates for the operator to set up the machine from surface.
You don't have your boobs extracted either.
Really, really interesting in that for us to do that, if we didn't have it from surface, we'd have to bring in almost 30 people just to get that guy down underground. And so now he's sitting on surface, able to make that kind of a thing happen. And then we started to speculate about what the future would look like and creating operation centers where I had been doing some work for the federal government where automobile companies were starting to hand engineering drawings from Canada and the United States into Europe and then into Japan and cut the engineering cycle down to 1/3 of what it was because they were working around the clock on the drawings. And I said, well, geez, we could do that with mining equipment now. And so we started talking about mining operation centers where you had head frames all over a local area and then all over the world being able to run machines. So we created one. In this room here, there was every piece of unit operation for telerobotics for mining, all done and operated from that surface control room in one mine. And every single bit of it was all operated over the communications network that we had originally built. But communications and positioning were the key technologies that we had to solve. So now I want to talk to you a little bit about some different subjects because I've gotten to be a pretty good mining engineer, and so when people give me a call, I usually get these really, really difficult problems. And so I got a call about 4 years ago from a company down in Australia. We want to work on underwater mining. And I said, well, geez, that's kind of cool, but how are you going to communicate with the robots? Well, we're going to let them autonomously run around the bottom of the ocean. And I said, no, I don't think you're going to do that. I don't think anybody's going to let you. And so we started working on a new kind of communication system. It comes back to these same key technologies whenever you're in mining. Telecommunications, positioning, navigation, what software you're going to use to run it, what methods are you going to use to actually do the mining, and then how are you going to make money at doing it with the equipment and the process systems that you have. So this is what's being made in the bottom of the ocean. It's actually black smokers. They're down in the Marianas Fault, and the idea is to mine them once they've gone through their active period. And the reason you go in after the active period is there's a lot of animals around the outside of this, like clams and others that are still down there, because they start to breathe in this material that's coming out because they now live in a chemosynthetic world as opposed to a photosynthetic world. So you can't just cut them out, because if you started mining them, all this material that we would consider pollution today up here is what these animals breathe in. And so you have to wait until the earth decides to seal up all that stuff to go in and mine them, if you're going to mine them at all. And you can see down here, these are some of the tube worms and some of the things just off to the side because they're waiting for this hydrogen sulfide to come out to be able to run them. So we started to work on how might you make this happen. Well, communications is the key. But you couldn't use radio because radio won't transmit through water, not in any capacity. So we began to speculate on using light and free space optical communications. And so after the CRC work and OCE work and commercial work with FedNor and a bunch of people, we ended up making this device, which is a 40 megabit per second free space optical communication system. And we patented not only that, but we patented the frequency division multiplexing as well as the time division multiplexing, which sent GE off the deep end because we now own the entire optical frequency spectrum in our patents for all optical communication in free space, and GE got a little upset about that. But, you know, so what? It's just GE. And so now we speculated in how this might look, for example, in an oil field in the bottom of the ocean, with our optical communication systems providing high bandwidth operation to untethered robots that all could be run from a ship. Because the oil today that you're looking for is going very, very deep under sea to the point where you can't, you're going to have to be able to move ships because the oil rigs aren't going to be long enough and the metal isn't going to be strong enough to allow you to drill at 8 to 10 to 12,000 feet underwater. And so this was a speculation we did actually for BP, which they didn't have, by the way. This is a really unfortunate, it's too dark, but it was a swarming set of robots that were working on how to map black smokers. And then this is what we did with the Ontario government, or what we're in the process of doing now with the Ontario government through NOHFC, and that's the building of a ship, which we have already, and a series of buoys running robots underwater. And we happen to do that off the dock of my house, where my wife's very patient with me. And she lets me run my boat and my research through the house, making hamburgers for all of us as we go, usually. But this video here is probably a pretty good video because, well, you can't really see this underwater without buying a bunch of special photographers and all this stuff. What this guy is doing is teleoperating a robot using optical communications. And out of a virtual, I won't call it a virtual because it's not virtual, out of a teleoperations chair. And the optical communication system is providing the video back and the control signals to the machine. Interesting, that gets you back into guys in the military who get quite keen on highly secure communication systems and all this kind of stuff. But so far, we'll see where that goes. It also opens the door to a bunch of other things. Along the way in all this, some people at a test site, an analog test site for NASA called Pavilion Lake, found out that I had the technology to be able to communicate through water. And so at the Pavilion Lake test site, they're doing analog missions of simulating geologic missions to Mars and looking into microbials in the bottom of this ocean, or the bottom of this lake in BC. And so we get a call to begin to work on it. The other thing we did is not just knowing that, but we had built a strategic plan for the Canadian Space Agency on what mining on the moon would look like. And we did this in a way where we talked about how to integrate all the various organizations in the country and bring all this together so the CSA could make this kind of thing happen as kind of an overall roadmap for them through the terrain. Because if you look today at what's happening in the whole space mining business, everybody's playing with toys, even NASA. They're just tiny little devices. And if you actually want to go do anything real, you're going to have to move the scale of what we're doing up to terrestrial scale. Actually, you know, a very simple thing that nobody really grasped until I was talking to them was I said, 1/6 gravity, and we use gravity today to mine. If you want to build a mining machine on the moon, multiply by 6. And they all went, well, we couldn't launch that. And I said, well, that's the problem. You're going to have to figure that out, because until you